All right, well, happy Monday again. This is a good, appropriate start for Mondays, I guess. It's 11, it's not too bad, right? I don't know what time you have to get up to get here. I had a meeting on campus at 9:30, and I was really sad because traffic is worse the earlier it is in the day. Like getting here for 10 is not so bad, but like the 9:30 just threw everything off. And then they didn't have Diet Coke. I drank all my coffees already. I brought two coffees with me. I drank those, so now I'm on regular Coke, which is great for my diabetes. So I'll probably be even more loopy than usual. Believe it or not, I get more loopy. Um, we're talking about loops today too. So perfect. I didn't even plan that. That was unintended, and I'm so excited. All right, so we're going to keep talking about loops, and we'll have our lab on loops. Again, sorry I missed you on Monday. After 5 days of antibiotics, I'm feeling pretty good. So that's exciting. Thanks to modern medicine. It's good stuff. We'll do a lab on loops. We'll have a lot of fun. I think it's a lot of fun. You might not think it's a lot of fun, but it's good practice. It's okay. So, has anyone ever seen ASCII art before? You can make pictures out of text. It's really fun. Let's just look at like images here. You can do all. Oh, okay. Yeah. Okay. Maybe I should search better next time. But you can make all sorts of pictures out of ASCII art. And we're going to make really boring pictures because we're going to use loops. So we can make rectangles, and we can make squares, and we can make triangles, and we can make diamonds or rhombuses, I think is the technical term here, right? Because we're technical people, we should use technical terms. We talk about a rhombus all the time. Everyone knows what you're talking about. Yeah, definitely. Yeah, I mean, why learn the big fancy words if you never use them? Right? We got to use those big fancy words. All right, so last time we left off with input validation, one of my favorite things to do with loops. And I was real confused on Wednesday, still wasn't feeling great, on how you make stuff lowercase. It turns out you don't make whole words lowercase in C++ because it's stupid. You can make one letter at a time lowercase because we can deal with characters, and that's why I was expecting an integer, because characters are really integers. It bothered me like for days until I was like well enough to actually go Google here and make some sense of what I was searching. So dealing with uppercase rock versus lowercase rock sucks. It does. So things we can do in our menus, we could ask them, hey, just enter one letter. We could just take one letter at a time. Or I can just take the first letter of what they did enter and compare that and say, if the word they entered started with an R, they probably meant rock. Remember, we can get at individual characters in a string because they're that sequence type. We can use the at notation, I think. Or maybe to look at the first letter, see if it's a P, look at the first letter, see if it's an S. They probably meant rock, paper, scissors. So we'll look at doing one of those here instead. So I'll leave this one here. There we go. Control E and Control C will comment stuff out if you like your keyboard shortcuts. Sure, that's just a fun fact. Or you can go to the edit menu, right? It's in this advanced. You can do one of these ones here as a comment. Yeah. Toggle block comment, E and C. I don't know, it's in here somewhere. This one, comment selection and uncomment selection. There's always lots of ways. So if we wanted to look at just their first letter, right, I can say while my input dot at 0, remember when we start with strings, the first character is always index 0. You'll get used to it eventually. Right, this is not new. I know it's Monday. It's all right. We're going to start slow. All right, now I can take, is it just two lower? I think it's two lower. Yep, two lower, given the first character. So I grab the first character, lowercase it, because I don't know if they have caps lock on. Some people love to yell online, and maybe they just leave their caps lock on all the time because they're always winning arguments online. If you yell online, people listen to you more. I've been told. So does that equal then? Now, I'm not going to use the double quotes here because I grabbed a single character. So in here now, I'm going to use a single apostrophe, right, to compare a character to a character. This will compare character to character, right? Or I don't know, first character to character R. Right? So I can say that, okay, if it's an R, but now I really want if it's not an R, right? Because I want it's not an R, and it's not a P, and it's not an S. If it's not an RPS, they probably didn't enter rock, paper, or scissors, right? So just giving us some options here. So this will be not equals an R, right? And it's not equal to this, and it's not equal to that. And this gets a little long here, sorry. If you don't have the font zoomed in as far as I do, it probably fits on one line here. You won't feel so bad about it, but that'll be okay. Let's see. Oops, too lower. I missed my parentheses here. So it's all of this like line here. It's really upset because I want too lower of this, not equal to that, and too lower of this. What it's suggesting is not actually helpful here. It's saying, hey, you probably wanted to do a different thing, but that's not a useful error here, which is unfortunate. It did not read my mind. It is not the smartest tool out there. It's a pretty smart tool, but it doesn't always get it right. So it'll like, something's weird here, and maybe that suggestion was bad. So, and again, invalid entry, I'll just copy that, and then we'll ask for their input, and then we'll check it again. Did they enter an R, or a P, or an S? Right, we can check. If it's not one of those things, keep them in here until they give me something that is valid. And this is what the whole point of the validation loop does. Keep on asking until they give me something I expect. Right? And this is my little shortcut so that I don't need to say lowercase rock, uppercase rock, any different combinations of capital R, lowercase, rest of the letters. Like, people will enter the weirdest things. Now, and if you want to just completely avoid dealing with strings anyway, have them enter numbers. Right? You can use some sort of menu style input and say, hey, enter 1 for rock, 2 for paper, 3 for scissors. That works even easier, right? So we could say, hey, let's do cout, enter 1, rock, right? I don't know. Let's be pick a choice. I don't know, pick one, and then you could add in your own new lines if you wanted with those \n's. Right? Do we look at \n's for new lines ourselves? Do we look at those? No one ring. Okay. So if you want to do your own new lines without having to do those endls, you can use a \n for new line. Backslash is a special character. That's the escape character, so you can get special things. You can also do \t for tab if you like tabs, so things will be down a line and then tabbed in one, just to line things up. Really just a style preference here. Some people really like them, some people don't. So we'll do 1 for rock, 2 for paper, and 3 for scissors. Right, and then I'll do another end line here, and then I can get an int for throw, and I can cn the throw. Did I already use throw? No? Why is it not like throw? What did I do wrong? Huh. I think I confused it. Oh. Throw showed up in purple because it has a special meaning to C++. So this would be like user throw is safer. It's purple, it's a reserved word. It's one of those ones you can't use. There we go. So user throw. Sure. Now we can do that. So this menu then is just going to say, well, it's not a 1, not a 2, not a 3, or if it's right, any sort of whatever we want to check here is fine. So my user throw is less than 1, and user throw is greater than 3. Right, that defines that this is now invalid, because if it's a 1, it's not true, the loop doesn't run. If it's a 2, it's not true, the loop doesn't run. If it's a 3, it's not true, the loop doesn't run. But what happens if it's a 0? 0 is true here, but 0 is false here. True and false would be false. So I can't use and here. And's the wrong one here, so I want an or. If it's invalid this direction, or it's invalid this direction. Right, so this is sort of the opposite. Here I'm saying if it's invalid, keep running. Where with this sort of loop is saying if it is not valid, do run. There's just a lot of different ways you can put these logical operators together, right? You just got to step through and think for a second. Do you want this to run or not? And what's the condition? So we want this to run if it's not good here. So not good is this way, too low, or not good is this way, too high. Right? I don't want to define what is good. I guess I could. I could say this is the good option and then do not that. You can write these like 50 different ways and people will go crazy. It'll all get the job done. So in this case, this is invalid, too low, or invalid, too high. We just ask them to do it again. We'll keep on picking. Now, using the numeric input is actually really nice and easy here because I can pick a random number for the computer really easily. right? It makes life pretty easy. So if I wanted to pick the computer throw, right, we can use random for that. So int computer throw is going to be rand modulus 3 will give me 0, 1, or 2, right? And then I can add 1 to it, right? So I get 1, 2, or 3 from this. Now, if it's 1, the computer picked rock. If it's 2, the computer picked paper. If it's 3, the computer picked scissors. It's pretty easy. So now I can see, did we win, lose, or draw? Right? The little shortcut here is check for draw first. But that one's really easy, right? If the user throw is equal to the computer throw, see how tie or draw? Right, that's the easy one. Then, now do you want to do win or loss? Either one works out the same. Win, okay, so win. So if the user throw is equal to rock, and the computer throw, oh my goodness, come on, type ahead. Computer throw is equal to, so if we're rock and they're scissors, oops, double equal sign here, double equals, right? That's one way to win. This and this. We're rock and they're paper. No. We're rock and they're scissors. We want to win. That's one way to win. Or if the user throw is paper and the computer throw is rock. If we're paper and they're rock, we win. Or if we're scissors and the computer throw, oh my goodness. Computer throw is scissors, we win. If any one of those, this, or this, or this. Now, we know because of order of operations, ands happen first, so this will work. I'm always scared to do that because I can never remember which one's which. So I'm going to throw some redundant parentheses in here because they make me happy. Right? Nothing wrong with adding some redundant parentheses because it makes it visually easier for us to understand. Right? Because we might not remember, and that's okay. Right? You don't have to keep everything in your head. It's not worth it. So this and this, or this and this, or this and this. Right? Any one of those pairs means we win. Player wins. And then if you didn't win and you didn't tie, do we need to check for loss, or can we just say else you lost? Right? Save yourself the checking here, because it's got to be one of those three things. You either won, you lost, you drew. And we already checked for the first two. Right? So you don't need another if check here. You could if you wanted, but you're doing more work than you need to, right? Be lazy. Okay? So using the numeric input's nice and easy here. We don't have to do it with numbers, though. If we wanted to, we could say, okay, let's pick a random computer throw, and then we have a string for computer throw, computer string throw? I don't know, sure. Why not? And then in here, we can say, hey, if the computer throw is, type ahead is not working for me today. Maybe computer's the wrong word to use. Computer throw is equal to 1, then my computer string throw is equal to rock, right? We could do it the long way here. You don't need to finish all that, right? And then we could check, hey, if my throw, what is it here? If my input is equal to rock and my computer string throw is equal to rock, right? We can do all sorts of these sorts of checks here, right? But you can see why this is longer than just checking numbers. Now, what's nice about this, though, you can see rock here, right? That's really easy to see. We've got these magic numbers. You've got a number that means something, but we don't know what it means. So we can fix that, right? We can come back here, we can add some constants if we want. Again, some people really like to put them at the top. I don't care much. I mean, it's good habit, sure, but like there's a button you can click that'll do it for you. So most of the time I don't bother scrolling it back up to the top. So I'll say, hey, constant int rock equals 1, constant int paper equals 2, and constant int scissors equals 3, right? And then I can say, okay, if the user's throw is rock and the computer's throw is scissors, right? Doesn't this look a little nicer here? Now, you might not remember that rock is 1, but does it really matter that rock is 1? We don't care what they picked for rock, really, as long as we got it right in the menu. I guess it's kind of important to have it right in the menu, but again, nothing's going to be perfect here. So this will be paper and rock, and then this is scissors and paper. Okay, so this is much prettier, right? To avoid those magic numbers. So we like that. All right, all of that to play rock, paper, scissors. Now, I do have a strategy, and a lot of times it works with people. I know it's hard to win at rock, paper, scissors because it's mostly random. But it turns out rock, paper, scissors is more of a mental game. So if you tell someone that you're going to play rock, they don't believe you. Because why would they believe you? Why would you tell them what you're going to play? So I tell people I'm going to play rock, and then I actually play rock. And more often than not, I win, because it just confuses them. I'll do like 3 or 4 times in a row, and I'll just keep doing rock. So now I never beat my kids because they figured it out. That Dad's dumb enough, and he'll just keep doing rock no matter what, because it's funny to me. So they will always beat me at rock, paper, scissors because my kids figure it out. But then I'm like, okay, I'll bet you $10 next time. They're like, oh, I don't know about $10 that you'll keep doing it. That's all. That's just a fun side story. So it's a mental game. That's what rock, paper, scissors is all about. All right, so we did validation loops. Lots of while loops, right? While something is true, keep on going. Another fun one we can do with a while loop is we can have the user enter something until they're bored of it, or they run out of things to enter. Like if you, at the end of the day, need to total up all your receipts in your drawer, right? You're probably just going to enter a bunch of numbers, enter a number, enter a number, enter a number, enter a number, enter until you run out of receipts, right? So we can have some sort of a loop with some people call them a sentinel value, a value that's deliberately bad, so that you know the loop should stop. So we can say, hey, let's have here's a double for, we'll go sum, starts at 0, and then I can say, I want an int for receipt. Receipt is 0, sure, and while receipt does not equal, now I'm going to pick a number that you shouldn't have in your drawer, right? 0 might be nice actually to use here, but it's going to mess up the rest of my loop. So I'm going to say like -1. We probably don't have a receipt for -1. You might if you have returns, but we're going to pretend like returns don't happen because that makes life harder for us right now. So as long as you didn't enter a -1, let's ask the user to enter the receipt. So we'll say enter the receipt amount or -1 to stop. Right? And then I can input the receipt. And I can take my sum and I can add to it, right? This plus equals shortcut. I can add something and assign right back to sum. I can add the receipt to it. Well, that works, but if they enter -1, now I just subtracted 1 and I'm sad. This gets a little messy here. So let's actually say 0, and then I'll just set this as 1 because it doesn't matter. So don't enter 0. If you enter 0, we'll stop, because if you add 0, it's not going to change the sum. And then my loop will stop. This is probably pretty good. Hopefully your store doesn't give stuff away for free, because that would put your store out of business pretty quick, right? So again, I'm starting out, it doesn't matter what I started at, because I'm going to get their input here. So this is like a throwaway value, make sure the loop runs, right? Because a while loop is a pre-test loop. It's testing first. It may never run. So if I set it to 0, the loop never runs, and it's not going to do what I expect it to do. So I have to give it something to make sure the loop runs. I'll ask them to enter values, and I'll keep adding to the sum. And when I'm done, I can see out your receipt total is, I can output the sum. Now this way, they can just enter, hey, this was a $10 purchase, here's a $15 one, $2.99, whatever, and they just keep on going through their stack. Eventually they get to the bottom of the stack and they give me 0, they're done. So this loop will just run until you're given this sentinel value here. So 0 is my sentinel value, a deliberate, I don't know, a weird value. Weird. So like something you wouldn't expect to see in that pile. Right? We can do that sort of thing. I think the book has examples like, hey, let's total up how many points the team scored in the season. You just keep on entering number of points here. 0 is a valid point entry. So you probably want to start with like negative. It's hard to get negative points unless you're in golf. But that's not even a sport, so we don't talk about that. This sort of thing. So we can anytime just keep on asking and asking and asking and asking until they give me something that's weird. Then I can stop. So we can just keep on totaling it up here. So this will give me the sum here. If I wanted, I could also calculate the average while I'm at it. Right, because why not? We like doing that sort of thing. So to do that, I need a receipt count. Right, starts at 0. Every time they enter something, right? I want to add to my count. So we'll take my receipt count, and I can say plus equals 1. Let's add 1 to it. They entered a receipt, entered a receipt, entered a receipt, entered a receipt. Now, if they entered 0, though, I don't want to count that one. So this gets a little messy. I guess we need to say, hey, if my receipt does not equal 0, then I should count it here? Sure. It's probably spelled it wrong. That doesn't look like receipt. That's okay. You know what it meant. Okay, so we can keep on counting here, and then we can give them the average. So your average receipt is, right, my sum divided by the count, receipt count. And now we can calculate the average. It's not so bad, right? All right, so let's give that a try. Oh, that's all the way at the bottom. I should just put these up at the top here. That's all right, we'll give it a run. I want to make sure it works, right? All right. Guess a number. 50. 10 guesses. Oh, goodness. All right, 75. Too low. 87. Too low. 94. Too low. 97. Too low. 99. Hey, 99. Nice. Went all the way up. All right, and then rock. 1 for rock. Sure. Okay, the receipt amounts, or 0 to stop. So we should just be able to enter. Let's do, hey, here's a $10 receipt. Here's a $20 receipt, $30 receipt, and 0 to stop. Total 60, average is 20. The math checks out here, right? It worked out pretty good. And you can just keep on entering values here. So we can use these loops to let people enter values until they want to be done, which is nice because sometimes people don't know how many times they want their loop to run. Okay, so those are some while loops and some other while loop examples. Another kind of loop that is super common is a for loop. Now, for loops are great if you know how many times you want it to run. Because we're going to see you have to tell the for loop how many times to run pretty much. So with a for loop, let's say I wanted to enter, I don't know, because I know there's always going to be 9 games in a season. I can ask them to enter something 9 times. Sure, why not? So we can say for. Now, with a for loop, the stuff that goes in the parentheses is a little weird here. You have an initialize, you have a semicolon, you have the test, you have another semicolon, and then you have the update. It's the weirdest looking thing. So it's just a condensed way of doing a for loop, essentially. It's like a shortcut. So we can say, hey, int score is 1. So that's my initialize. So I'm starting a value, just like I did up here. Hey, my receipt was 1. Here, I'm starting the value. I'm initializing the value. Okay, so score is 1, then my test. So score is less than or equal to 10. Right, we'll go 1 to 10. Why not? Right? Another semicolon. And then the update. Score plus equals 1. Now, oftentimes, adding 1's super common. You can just say plus plus. And plus plus will just add 1 to the value. Again, it's a post increment. There's all sorts of things about it. It's not. Some people love putting the plus plus here and it will pre-increment. Some people like putting it at the end of a post increment. Someone told me once the pre-increment's faster. I didn't care because I'm not doing anything a billion times. If you start doing things billions of times, then faster matters. Right? For our purposes, it's not. No one will care. And it does slightly change how it's used, but that's okay. So score plus plus. So this is the update. So just like a for loop, right? That would have score is 1, right? Our receipt is 1. The test here, right? And then the update. So what's changing here? So our case, we're just inputting the receipt. We didn't know here, right? This case, we're just going to say scores plus plus. So the exact same way you can do this with a while loop. You can say int score is 1, while score is less than or equal to 10, set of parentheses, and then inside your loop body, right, you could say score plus plus, right, other loop stuff here, right? So initialize, test, update just gets thrown in one line. It's just a shortcut for us. For loops are real common. So it'll look a little funny for a while. We'll practice it a bunch. We're going to do all sorts of for loops for drawing ASCII art because it turns out when you want to draw a rectangle, you probably know how big the rectangle is. You don't be like, keep entering a number, keep hitting enter until you're done entering rectangle lines. Like, I guess you could draw it like that, but that's a little weird. So score this way. Okay, so we'll say cout, enter score number, and then the score. And then if we wanted to get, I don't know, a total score, 0, and then we need a place to enter here. I don't know, input, sure. And then we can see in the input, and then we can take my total score plus equals the input. 10 scores, sure. And again, same idea inside the while loop. This other loop stuff here, we'll just throw that in. Works the exact same way. More tabs. Oh goodness, there we go. Right, does the same thing for me, but I know how many times it's running. So we did while my guess was not equal to number of guesses and number of guesses was less than max. This worked out nice as a while loop because either one of these could stop early. Right? Doing this as a for loop to say, okay, my number of guesses is 1 as long as number of guesses is less than guess number. Like, you could do it as a for loop, but then trying to end it when we did guess the number right is weird versus just max guesses. So you can always replace a for loop with a while loop, but it gets harder to replace while loops with for loops. That's all. So we just use them as shortcuts most of the time. But we'll see for loops a lot of places. They're a lot of fun. Other cool things we can do with for loops, right? So if, we'll just put it down here. So we can say, enter your name. And then I can see in the string for name, see in name. Now, remember when we looked at strings, you could do a couple cool things with strings, right? We can get characters out at individual locations. We can figure out how long strings are. So we could loop over a string, one character at a time, right? So I can say for index is 0, index is less than, this is my name dot, is it size? I think it's size, right? Will tell me how many characters are in that string, right? The size, and then index plus plus. Nope, that was a semicolon, sorry. So initialize, start at 0, as long as I'm less than the size, which works out perfect for index based. So if Eric has 4 letters, I have indexes 0, 1, 2, and 3. Right? I don't want to go all the way to size. I want to stop before I hit size. There is no index 4, right? So no letter here, right? Because we start at 0, that's all. So we're always going to be less than the size of something and take index up by 1. So in here then, maybe now I want to upper the name at index. I don't know why, but we can uppercase everything. And then I'm not going to do the end lines here because I want it to just be all smushed together here. Right? Take all the output and just stick it, stick it, stick it. Don't go down, don't go down. When the loop is done, then I can output an end line. Okay, so now I've printed out your name as uppercase. Sure, that's really fun. We could change it now if we wanted to, right? Instead of just outputting, we could say names at index, right, is equal to the uppercase version of that. So this is how you can uppercase or lowercase a string the hard way. Usually there's like a one-line option in like most languages, but C++ is dumb. So you can loop through, not only just print it one letter at a time, but we can go change it here and I can output name this way if I wanted as an end line. So now I have an uppercase Eric. It's very exciting. Now I can start arguing with people online because my name's all uppercase. That must be important. Sure. This is fun. So looping over strings is pretty easy here. If we wanted to do something like, hey, let's count how many vowels are in something, right? We could do a similar thing. Let's loop through, start at 0, go up to the size, one letter at a time. Let's check if it's a vowel. Right? Is it an A, an E, an I, an O, or a U? Sometimes Y? Do you like count Y's as paths then? Is it sometimes a vowel? That's a bad English joke, sorry. English sucks. It's a really hard language. Teaching my kids English has been awful when we homeschool our kids. Like, they're like, why does this like word with an OU sound like this and this word with an OU sound like this? I'm like, I don't know, kid, because we stole from a bunch of different languages. Like, really, like, is it a Germanic root or is it Spanish? I don't know. It's just a mess. And don't get me started on tortilla. Like, it's not even an English word, right? Like, we use it in English now and it's in an English dictionary, but it's not an English word. They're like, why does it sound like a Y? Okay. All right. So it's a for loop. Lots of fun things we can do with for loops. I think they've got some other examples. For loops. Oh, technically, they're all optional. You don't need to have anything in those sets of semicolons here. So this will be an infinite loop. Because why not, right? So for, semicolon, semicolon. Hey. Right. It'll just run forever because there's no test that makes it stop. Sure. Let's see if we can get an uppercase Eric. And then we'll crash eventually. I don't think it'll crash. It'll just run forever. 50 is too low. 70, oh, is it 94 again? 90? No, too high. Okay, so we did the random seed. Okay, so 75, too high. 64 is too low. 68, too low. 71's too low. 73. All right, 7 guesses. Rock, 1. Receipt amount, 0 to stop. Average receipt is negative NaN ind. That's not a number. Right? When you divide something by 0, it's not a number anymore because you did a bad math thing. You can't divide by 0. It didn't crash, but it gave me garbage, so that's fine. So yeah, score 1, score 2, 3, 4. We're not really doing anything with those scores. All right, enter your name. So all lowercase. I think we got an uppercase here a second. I just wanted to make sure it came out. There it is. There's uppercase Eric. So in terminal, the terminal output, if you start highlighting things, it kind of pauses for you, which is really nice here. If I highlight something, it stops the output for a second, and it's just going to keep on going because it never ends. Again, we can do that with the while loop as well. So Control C will kill it if you need to kill something, or you can just hit the X. Right? Same idea with the while loop. So just while's a little harder because you have to have something here, but you can say while true for an infinite loop. How about this one's B, right? B, we'll never get here because that's all right. Another infinite loop. Probably shouldn't run these ones. We'll just get stuck here. Should I comment? I'll comment them out. Okay. I've got doubles. That bothers me. Okay. So you can make infinite loops. So these are optional. A little messy if you want them here. All right. I think those are fun. Yeah. Savings, input values. Yeah. Again, if you know how many times it should run, use a for loop. It's easy. If you don't know, or just keep going until they tell me like, hey, they want to quit, sure, we'll use a while loop. It's pretty easy. So we can make this whole game here loop if they want to play again. Right? So we can say, hey, I want a char for play again equals a y. And while play again equals a y, let's do the whole thing here. I'm going to throw all of this in a while loop here. Oops, nope, that one. Here we go. So you kind of follow these little lines here. Again, that's how I do it here. I follow these little lines, and I know I was one line in because I started the while loop. So sometimes it can be hard to line up all your curly braces. The other cool thing is when you click on one, it highlights the next one. So it's kind of highlighted here. I don't know if you can tell. And then down here, it's highlighted as well. That's just a nice little thing. There's some setting you can do that will colorize them, which is really nice, but it doesn't come default. And I try and always run the defaults because when I don't have defaults on, it confuses other people because they don't have those things. But colorizing is a very common thing that like the first set will be green, the next set will be purple, the next set will be pink. Like that way, visually, color-wise, you can see instead of just relying on the lines and things. So turns out people like colors. So, all right. So all of this now is going to be an infinite loop unless I ask them to play again, right? If you don't change what's happening here, you might be stuck in an infinite loop. And infinite loops are sad because, I mean, playing guess a number is really fun, but eventually be bored at some point. I don't know how long you can play. You got a lot of time to kill before lab between classes, so maybe you want to guess a number a lot of times. But so eventually we should go ask them, do you want to play again? So near the bottom of the loop, then I'll ask them, do you want to play again? Want to play again? And then again, I'm going to prompt like Y or N here, like as a suggestion, because pretend like your users are, I probably shouldn't say dumb. Pretend like your users are 5 years old. You have to be very explicit with a 5-year-old. Right? Does that mean explain it to me like I'm a 5-year-old? When you're programming, explain it to your users like they're 5. It will save everyone time, hassle, and headache and energy because you've explained it to them like they're 5. And it's very clear. life is good, right? Just, it's okay. And then we can cin, play again. Now, it's only a single letter, right? So Y or N, sure, that should work. And then again, if I wanted, I could probably 2 lower this, right? Whatever they, oops, I can't do it there, shoot. Play again. I guess we'll check it at the top. Why not at the top here? So while 2 lower of play again equals a Y, just in case they entered a capital Y, right? Why is it red here? See how it's ambiguous. This happened to me before, right? What did I do wrong with this? I don't remember why. All right, it still runs though. That's super weird. Why did that happen? See how it's ambiguous. Error? Sometimes that's helpful. I don't know if that's going to be helpful or not. We've included, along with namespace standard. Huh. What did I didn't change anything. Right? We added in a 2 lower. I'm super confused now. I'm just going to pretend like it's not there. Is that okay? Because I don't know why. I'm really confused right now. It'll probably go away. All right, I'm just going to close Visual Studio. It's going to bother me. We'll close it and reopen it. Sometimes that does the trick because it's a computer, right? Did you hear that joke about the 4 engineers who got into a car and it wouldn't start? The mechanical engineer was like, oh, the starter must be bad. The chemical engineer was like, oh, there's probably impurities in the gasoline. The electrical engineer is probably like, oh, the circuit's not connected. And the software engineer is like, hey, guys, let's get out and back in the car. I mean, it works sometimes, though. Let's try it. Let's try it. The red lines are gone. I don't know. I don't know. Okay. Sure. All right. So anyway, this sort of idea here, it just works until they enter something that's not a Y. You want to play again? Yeah. You want to play again? Yeah. You want to play again? Yeah. Awesome. So depending on how nice you're feeling, you can either check that it's affirmative or not negative. You could say anything that's not a no, let's keep on playing. And make them enter no versus anything that's not a Y makes it stop. It's a very slight difference, but totally just a style preference here. All right, so you can play your game over and over and over again. If you want to be fun, you can change these things, like max guesses could be input. And say, hey, how many guesses do you want to give someone? I want to give them 50 guesses. I want to give them 2 guesses. I don't know, whatever, right? And then you could even say, hey, how high of a number do you want to guess? And change your 100 here. It doesn't have to be based on 0 or 1 to 100. It could be 1 to whatever. You tell me how high you want to guess a number to. Hey, I want to guess a number to 1,000,000. Okay, sure. We just plug in 1,000,000 here. You got all sorts of options we can do here, which is lots of fun. My kids think it's really fun to guess a number up to 1,000,000. You're like, hey, kid, look, you only need like 9 guesses. They're like, no way. You can guess a number up to 1,000,000 with 9 guesses? Maybe, is it 11? I forget what it is. Some number of guesses. It's not a lot. It doesn't take a lot of guesses. So they always think that was fun. You think your parents were lame? Try having a computer science prof for a parent. It's real rough on my kids. I feel so bad for them. Okay. So do some loops. So 4 loops, sure, that's all good. Let's go back. More for loop examples. Other fun ones. What else do they have in here? Finding the max. Oh yeah, min and max. These are fun. So if you wanted to know the minimum number or the maximum number in a list, right? In English, if I just start listing numbers off at you, what are you doing in your head if you're going to find the largest number? I say like 7, 12, 5, 15, 2, 100. Not like, what are you doing in your head? Yeah, you're comparing, but what number are you always thinking of? The highest, right? You don't care about anything if it's not the highest. Or you just ignore me if I don't say a higher number. You compare and you throw it out. So you have to hold on to the higher number. So we can say, hey, int highest number, and then an int for number, and then don't know, how about while, let's do, sure, number's 1, something here. While number does not equal 0, we'll see out, enter a number, or 0 to stop. Because 0 is not really a number, right? Isn't that what mathematicians say? It doesn't count as a number? Like, the pure math theory stuff just really hurts my head. It's fascinating stuff, but it gives me a headache anytime I start talking with mathematicians. All right, so enter a number, and then we can check the C and the number, and we're going to compare. Number, if my number is greater than the highest number. Now, I didn't start highest number somewhere, so how about we start at 0? That's probably a safe place to start. Some people like to give you negative numbers to mess with you. We're going to pretend like no one's going to mess with us. Is that okay? I mean, we could start at like negative something, but we'll just pretend like they won't do that. So if the number's greater than the highest number, I'm going to change highest number. Highest number is now the number. That's it. That's the only thing I'm comparing, and I'm keeping highest number around if it's a new high number. That's all it is. So I'm done. I can see how the highest number is the highest number. You could also compare lowest number. Like, you could do all sorts of things. The same idea works. With lowest number, you have to start really big, though. Right? Is there the shortcut for max? Int max, int. There. You can start with int max. This is a constant value here of 2,147,483,647, right? We looked at the binary stuff a while ago and you all forgot about it. That's okay. It's 32 bits. Right, worth of numbers, but -1 because we need the plus or minus sign. You don't need to memorize that. It's okay. Eventually, you'll take another class and you can play with it again, and then you can forget it. Some of you will think it's really interesting, and we'll continue on and do the really cool low-level stuff for the rest of us to make our computers faster, and we love you for it. Most of us will never touch it again. But that's okay, right? It takes all kinds of people. All right, so we could start the lowest as the max, and we can start the highest at the min if you wanted, right, to. That's probably more proper, right? So int min here, and int lowest number is the max, sure. And then I can check if my number is less than the lowest number. Lowest number, my lowest number. Number is the number, sure. And then I can also output the lowest number. Lowest number is the lowest number. Right, so these sorts of loops, we can do more things with them. They're lots of fun. In a for loop as well, like, hey, how many numbers do you want to enter? Hey, I'm going to enter 10 numbers. We could do it as a for loop. Instead of that sentinel value, enter a 0 when you're done. Tell me how many numbers you want to enter, right? That makes life a little easier for calculating, I guess not even average, because we can count it too, but it saves us a little bit of time if you tell me you're going to enter 10. That's all. So for loops are fun. Table of temperatures, those are fun. Yep. Plus, yeah, prefix and postfix. All right, fantastic. Yeah, loops and okay, we did loops and strings already. We're good. We're jumping around here. Loops and strings, nested loops. Now we're going to get into the fun stuff. So a nested loop, you guessed it, is a loop inside a loop. Well, we did one of those already with our guessing game here, right? I just did it. You didn't really think much about it, but there's a loop inside of a loop. It's a nested loop. Right? It works okay. So we can do that same sort of thing here with other loops. Let me put this at the top, actually. I'll move it down later. So we'll say int rows and int columns. Or, yeah, rows and columns is fine. And we can say, let's ask the user, enter the number of rows for a rectangle. And then we can see in rows. And then we can do the same for columns. Columns for a rectangle, and we can see in columns. All right, so if I'm going to draw a rectangle, rows and columns, right? I'm going to have this row, and then this row, and then this row, and then this row, and this row, and this row, on and on and on. And every column, right, goes this way. So I can say for int row is 0, row is less than rows. And I always start at 0. You can start at 1 and do less than or equal to. But most of the time, things will be less than, like when we're dealing with length and size and those sorts of things. So I'll always use zeros, right? We'll say row plus plus. Oops, row plus plus. So for every row, right, if I'm going to do a for loop, starting at 0, as long as I'm less than the number of rows you entered. If you entered 5, this will run when row is 0, when row is 1, when row is 2, when row is 3, when row is 4, and it will stop. It'll run 5 times, right? I get 1 for every row. Now I'm going to put another loop inside of this. So I'll say, okay, for int column is 0, column is less than columns, column plus plus, column plus plus, right? So for every row, I have so many columns that you told me, right? You told me you wanted 7 columns. This loop will run when column is 0, column is 1, column is 2, column is 3, column is 4, column is 5, column is 6. And then it stops. So I'll get 7 things happening here. So I can see out. I like the star character here. And again, no end lines, right? Because we don't want to go down a line. When we're doing columns, we want them to be in a column, right? Or in the same row, right? After that's done then, now I want to see out the end line because I want to go down to the next row. Right? So this should print out a rectangle of as many rows, as many columns as you told me. Let's give it a try. So how many rows should we do? 8 rows, all right, and how many columns? 3 columns. 8 by 3, let's see. Is that 1, 2, 3, 4, 5, 6, 7, 8 by 3? It did it. We have a ASCII art rectangle. You're all impressed. It's very exciting. But we can, yeah, I did the Control-C thing. It's fine. Let's just stop. Just stop. Okay. This puts a loop inside of a loop. So if we're thinking about how often something runs, right, the inner loop runs from start to finish every time the outer loop runs once. Just something to think about. So we can, if you want, like if you wanted to display all the hours possible on a digital clock, I don't know why you want to, but you could. We could say for int hour is equal to, now I prefer the 24-hour clock because it's just better, right? It's less ambiguous, and then if you're dealing with dates and times on computers, you can see specifically what it is without having to find AM and PM, and then it sorts better. So I'm going to say hour starts at 0, right? Just, it does. Okay, hour is less than 24, right? Because there is no 24 on the 24-hour clock. You go from 0 to 23, right? Hour plus plus. So for every hour, we have a minute, right? So we can say for int minute is 0, minute is less than 60, minute plus plus. And then if we want to show seconds, we can show seconds. You put a loop inside of a loop, 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 as many as you want here, right? So for int second is 0, second is less than 60, second plus plus, and now I'm going to see out. I'm going to see out the hours, a colon, the minutes, another colon, and then the seconds, and then an end line. Right? I want this to go down a line every time. Now, this is not going to format it nicely because I'm not going to have 2 digits for every hour and every minute. We could fix that if we wanted. C++, see out fixed width numbers, something like that. Maybe fixed width is wrong. Number formatting, here we go. Look at that. It's even from the Umish website. They're like one of the top hits. That's very exciting. Where is it here? Precision. Is that what we want? I don't think we want precision. You can set the width on a see out. No, that's not what we want here. I want set precision of a number. That's how many decimal places I get. I don't want that one. Where? Set precision. This is not helpful. This PDF was not useful. Bummer. Okay. See out 00. 00. No. 0. 2-digit numbers. I'm not sure what to search right now. Ooh, the Bing AI is going to help us here. Let's see if it comes up with a good hit. Nope. That's 42. It's full precision. Pad with leading zeros. That's what I want. Padding. Leading zeros. Okay. Set fill. Okay, so let's set the fill with 0, set the width to 2. Let's see if this works here. So we'll set fill of 0, set width to 2, and then throw that in here. And then we're going to cite our source because we're good people here, right? So just grab this, drop it in here. Now, I don't think I need the std thing. Did standard, set fill. Import, oh, we got to include IO manip for IO manipulation. Sure, go back and include that. All right, so I can set fill, set width, hour, colon. Let's see if that works for us here. I know you're very excited to see all the possible times. All right, well, it did it for my hours. It didn't do it for the minutes. I guess we got to repeat. Well, that sucks. That's a lot of copy pasting. But look, we have all the possible hours and minutes and seconds showing on our clock. It's still midnight. So turns out spitting something out on the screen is actually really slow for computers to do. So showing something on this console output takes a lot of time, right? It does not take C++ that long to calculate these things here. So if we don't output here, it's done like that. All right, I snapped too soon, right? It's done. It did all the loops. So the slow part of that is just spitting it out on the screen. That's all, okay? Just to be aware, right? It's not actually slow to calculate these loops. So, all right, let's do that for hour, and then the colon, and then we'll just copy paste this again here for minute, and then the colon, and then we'll do it again for seconds. Okay, so we'll set our fill, set our width every time. That should be a little bit nicer looking, I hope, because we'll just repeat ourselves, because C++ is dumb. There we go. And now we get everyone is padded to 2 digits, and we're happy. You look very excited. So that was a lot for this little example here. Sorry. What if we wanted to do milliseconds? Could we put a millisecond loop inside of this loop, inside of this loop, inside of that loop? Yeah, we could. I'm glad you asked. You guys are like reading my mind here, right? We would just do another loop. We're not going to bother. That's not worth our time, right? But you could, right? Just put loops inside of loops inside of those are nested loops. Okay, we're going to get sick of them. But drawing shapes. We're actually going to do a couple other shapes in lab because they're very exciting and it's good practice. It's a chance to think about what do these values mean? How do we change them as we go in the loops here? So we'll do a couple different loops when we get to lab time. It'll be a lot of fun, right? So this was rectangles. You could do triangles. You can do, I mentioned rhombuses. Those are lots of fun. You can do upside down shapes. So like you could have a left triangle, or you could have a right triangle, or it's an equilateral triangle, right? So here's like a right triangle that's on the left, right? Or I could do triangle this way, right? A right triangle facing the other direction, or I could do an equilateral triangle. Oops, one more. Right, one more row. Okay, aren't those pretty triangles? Right, and then the rhombus, right? You just kind of repeat the triangle thing, but going the other direction, and then you just start taking away your stars. Those sorts of things. Those are fun. You can print stick figures. Those are a little harder with loops because you're not repeating the same shape, but you could just output a stick figure if you wanted. So all sorts of fun ASCII art we can do. That looks like it's off center now, doesn't it? Is that just like a trick because this one's not? Doesn't it look like it's not straight? Is it just me? Okay. All right, so we're doing pretty good on loops. It's going to take practice. That's all right. It'll be a lot of practice. This part here is super important. Developing programs incrementally, right? You don't want to spend an hour typing out a bunch of code and then hit run and find out something didn't work, right? Write a little bit and run it. Write a little bit and run it. Write a little bit and run it. Kind of build it incrementally and check it as we go. Make sure every little bit that we write is working, because we're going to find mistakes, right? We're not perfect. No one has, to my knowledge, ever written a perfect English paper the first time, right? They always have a draft, and then they revise their draft. Even professional writers have editors, right? So don't expect your code to be perfect the first time you write it. That's okay. It doesn't have to be perfect the first time you write it. It's going to be close, and then we're going to tweak it. We're going to edit it, right? That's that process. That's what we want to get in the habit of doing. So we're going to try something and then see if it works. Try it and see if it works. we need to be able to understand what we're trying to do. And that's really the hard part. Like the hardest part of computer science is figuring out how to take a big problem and break it down into small enough pieces to tell a stupid computer how to do it. It's problem solving. It's the creative bit here that's the hard part of computer science. We just happen to know how to make a computer understand us, right? Because we're learning the syntax, we're learning another language. But taking the big problem and breaking it down into small steps is the hard part. And that's the skill of the problem solving and the troubleshooting and putting these things together and debugging and working through it that we're going to keep no matter what. Even if AI can write lots of code for us, we still need to put the pieces together. We still need to troubleshoot it. We still need to know, is it doing the right thing, right? If I give it this input, what's the output? And we have to be able to understand the problem well enough to say, okay, for this input, this is what the output should be. So we can check and make sure that it does the right thing. That's the hard part of solving problems, is you have to understand it well enough to know when this goes in, this comes out. And for basic stuff, it's pretty easy, right? I put in a bunch of numbers, here's my average. I put in a bunch of numbers, here's my highest. I put in a bunch of numbers. We haven't got very interesting stuff yet. But we'll get to bigger and bigger and bigger problems, and then we can see we can do cool stuff, right? Just by putting all these pieces together. So that's what we want to do. That's why you want to build it out a little bit at a time, test and validate, make sure it works, right? It's this iterative process, just goes over and over and over. We're going to keep on repeating, testing, writing code, testing, writing code, testing, writing code, or copying code from online, testing it, copy code from online, test it, copy code from online, test it, right? It doesn't matter where the code comes from. We still need to make sure it does what it's supposed to do. There's a really good flow chart here. It's safe to use for, flow chart. I think it's just anything here. This was a really good, where was it here? Someone had a tweet here, it was really good. I'm trying to think of where it is now. Where is it? I'm gonna have to go back and find it now. Oh man. It's safe to use AI tweet flow chart. Can I find it? Can my internet search find it? Oh man, okay. I think I remember what it was here. I wanted to find the source here because it's always better when someone else writes it here. But all right, the idea here, let's do this in Word because why not? I like diagrams. So we talked real briefly about doing some flowcharts and saying, hey, here's the decision point. I'm either going to go this way or this way. Sort of putting a picture of what is supposed to happen in our code. That works too. So I'm going to insert some shapes. Where'd my shapes go? Goodness. 3D models. No, icons. Having a time. Shapes. It's right in front of me. Shapes. So let's do a little flowchart shape. Let's do our little diamond here. And throw this in here. Okay. And then we get some text. Where's my text now? So, all right, this is why I use tools that are not Word, but you can make it work, because why not? Does it matter if the output is correct? Right? Doesn't matter. And we can say, okay, if it does not matter, then it's safe to use AI. So here's our, insert our little shape. Here's our result. Safe to use AI. Oh, sure. We'll just drag it down here. So, oh, look at that. I can put it right in my shapes. This is what I wanted here. Nope. Just want that word. Okay, so if it doesn't matter if the output's correct, go for it. Use AI, right? The chat GPT style tools, these large language models, are prose machines. They're designed to give you output that looks correct based on, hey, this is what I expect to come after here. It doesn't mean it's right. It just looks like it's right. It's giving you prose. It's just coming up with something that it thinks will look based on what it's seen before. It's not actually doing any work, right? It's just generating output here, okay? So if it does matter, if it's correct, the next important piece here, and this one's pretty critical here, right? This is the yes here. It does matter. Okay, we get another decision point. Look at that. There we go. You have piece to know if the output is correct. This one's pretty important here. So can you tell if the output is correct or not? Right? Do you have the skills and the ability to check it and verify it does what it's supposed to do? Right? If yes, go for it. Right? I can look at some code it spits out and tell me if it's going to do the right thing or not. For small stuff, right? I'm not even going to say for everything, because some stuff is just nuts that it gives you. That's okay. Right? It will take more time. But can you figure out if it's going to do the right thing or not? Yeah. If you can't here, right? Don't do it. Where's our not safe to use AI? And really, this was maybe this we should maybe specify here. This is and if you're using it and you don't really know, maybe safe to use AI. We should specify, because just because you think you're good enough, that's a lot to weigh here. So this is the no. Right? This sort of thing here. This is not the prettiest flow chart. This is why I want to go find the tweet online. Building these out by hand sucks. There's better tools for them, but this is okay, right? So if it doesn't matter if it's right, go for it. It's just fun. It's just a pros machine. If it does matter, can you tell if it's right? That's the critical piece, and that's what we're still learning. That's what we're going to learn all through school, is how do we find out if we're doing things right with all these tools, techniques, and tricks and things? How do we make the computers go beep, boop, bop the right way? It's really what it comes down to, right? It's pretty cool. We can do a lot of things with it, but we have to be able to know if it's doing the right thing or not. If you just grab something from online, just like grabbing code from online, like Stack Overflow, other places, and slamming it somewhere, you still have to know if it's doing the right thing or not. That's still the hard part of, did it actually solve my problem? Just because it came up on a Google search doesn't mean it's the right thing. You can go down some crazy rabbit holes. So that's okay. This sort of tool will make developers faster, will make us more efficient, and that's good because we're lazy people, right? Why do more work than I need to? Right? But the whole point, I would hope here, of you going to school and learning these sorts of things is not just to get a letter, not just to get a piece of paper to get a job, which is well and good and fine, and I understand the realities of the world, but to actually learn things, right? And these are one of the things that's important to learn, is how do we know if it's doing the right thing or not? Right? How can we check and see, okay, for this given input, what's my output here? And what are all the steps that have to happen along the way here? And that's hard to do. That's why not everyone does software, right? If it was easy, more people would do it. It's a pretty good job, not gonna lie. The software industry is pretty sweet. So you just gotta be careful, that's all. All right, that was a fun tangent. Any other questions about loops? If not, we got lab at 4 p.m. today, right? So go hang out, have some fun on campus, and I'll see you about 4 o'clock. I'll post the lab in Canvas. Again, we'll do the GitHub repository. Every time, it's just another folder. We clone the repository, make your project in that folder. You'll get used to it eventually. It's good practice, I promise. And then we can get our code committed and pushed to sync with the cloud. The cloud will have our code, and then we don't have to deal with code in Canvas, because Canvas sucks for code, and then life is good. Okay. I've not had a chance to look at your projects yet. Still just digging out from recovering from being sick. This week, I'll be looking at those first projects. So I think they went pretty well for most people. Not a lot of people had a lot of concerns, and that's good. It's just a quick little intro project. So we've got the next project we're working on already as well. So again, start early. If you haven't started yet, get started early. Just more chance to practice some things here. And we go from there. All right, thanks folks. I will see you this afternoon.